Hi guys! In this video, let's talk about kinematic equations. Kapag may sample problem, ano ba yung equations na gagamitin? And then, a little practice of derivation of formula. Okay? So, as a recall, horizontal motion is under kinematics. Kinematics is a branch of classical mechanics which talks about motion. We are describing the motion of the object or of any system using the change in position and velocity and by describing its acceleration. Most of the problem that you will be encountering involves UAM or motions of objects which has constant acceleration. This means that velocity is changing but then the acceleration is constant. Okay? We have here the 7 kinematic equation, but actually it's just the 4 kinematic equation here. Okay. The one that we derived last time. Okay. So, as a recall, so here's your average velocity. Average velocity is solved using this formula, the change in displacement over the change in time. So, delta is change. Okay. This is change. If that is change, of course, that is equal to your final displacement minus the initial displacement. Okay, the same with time, that's the change in time, this final time minus the initial time. And other formula for the average velocity is the average. Of course, this is the initial velocity plus the final velocity all over 2. And then we have also the formula for the acceleration, which is equal to acceleration is equal to the change in velocity over time. Okay, the rate of change in velocity. Okay, so we have here the derived equations from this 3. Okay, so ngayon, the question is, paano malalaman ano yung formula na gagamitin kapag may sample problem? Okay, so if you have sample problems, you have to look into the variables given, and from that, you will see what is the formula that you are going to use. Say, for example, the given are acceleration, velocity, or this is final velocity, okay, initial velocity, and time. So, with that, ito yung gagamitin na formula. Kapag naman walang acceleration, pero halimbawa, ang hinahanap ay final velocity, okay, you can use this formula and so on. Okay, you can use this table para makita nyo ano yung mga available na variables or na given so that you may know what equation will you be using. Okay, so I have here an example. The given on the problem are the following. Oops. Okay, say for example, the given is the initial velocity, the change in displacement, and the change in time. And you are asked to find the acceleration. So we'll be using equation 7. Okay, this is equation 7. From this, we can derive your formula for acceleration. Okay, derive natin. Of course, kapag may addition and subtraction, nililipat muna natin yung isang variable or yung set ng variable sa other side, or we transpose it on the other side of the equation, then it will change its sign, or we use the additive inverse. Okay, so let's just move this on the other side of the equation. So this will be your, okay, that will be delta x minus initial velocity times time equal to a t squared all over 2. And for you to eliminate the denominator, okay, multiply both sides by 2. So that will be 2 times your delta x minus initial velocity times time equal to a t squared. Okay, and then divide both sides by t squared. Okay, t squared. So your formula will be a is equal to your 2 times your delta x minus VOT all over t squared. And that's how you can solve for the acceleration this given using equation 7. So that's it. Next, for number 2, what if the given are acceleration, final velocity, the change in displacement, and you are asked to find the initial velocity. Okay, then walang given a time, we'll be using equation number equation. Okay, equation number 6. Okay, so from this, you can see meron tayong final velocity, initial velocity, acceleration, and the change in displacement. Okay, so let's derive. This is our equation 6. We are asked to find the initial velocity. So, again, transpose on the other side of the equation. So, that will be your final velocity squared minus 2ab o d or delta x. Pwede rin naman itong distance d na lang is equal to initial velocity squared. Okay, then to remove the square, extract the square root, okay, or get the square root of both sides, so that will be your VOs is equal to the square root of VF squared minus 2A delta X. So that's it. Ganun lang, maghanap ng formula. Tapos, kapag meron ka na yan, halimbawa, hinahanap din yung time, you can use another formula, okay, for you to solve time. Okay, for number 3, the given are initial velocity, displacement, and then time. We're asked to find the final velocity and the acceleration. So, here, ang gagamitin naman natin ay equation number 5. Okay, let's have equation number 5. So, here. So, final velocity muna. Ito kasi nga based on the available given. Okay? So, here we can rewrite this as delta x is equal to your initial velocity plus final velocity multiplied by time all over 2. Same lang naman yan. So, that you can have here multiply the whole equation by 2. That will be 2 delta x equal to initial velocity plus BF, okay, all over, times t. Dito pala tayo mag-divide both sides by t. Okay, dividing both sides by t, we'll have here 2 delta x over t equal to initial velocity plus the final velocity. And you're asked to find the final velocity, so this. So your final velocity is now equal to 2 delta x all over t minus the initial velocity. Okay, so that's it. For acceleration, of course, you can just use the formula for acceleration. Okay, you have acceleration is equal to your final velocity minus the initial velocity over 2 times time. Okay, so we can solve for it. Okay, or if you want to, you can derive from other equations also. Okay, so okay, and for the last example, we have here sample problem. Okay, Heidi is approaching a stoplight moving with a velocity of 30 meters per second, and the light turns yellow and Heidi applies a brake and skids to stop. If the car accelerates at 8.0 meter per second square, then determine the displacement of the car during the skidding process. Okay, so the given are, of course, we have here the initial velocity of Heidi. So that is 30 meter per second. Final velocity, here, it skids to stop. So the final velocity is 0 meter per second. And if the car accelerates at 80 meter per second, then determine the displacement of the car during the skidding process. Okay, so here. Okay, so I changed the solution. Okay, so here the equation will be from equation 6, we are going to derive delta x. Okay, so that will be our delta x is equal to the final velocity minus the initial velocity, the final velocity squared minus the initial velocity squared all over 2a. Okay, so here, sulat natin yung given. So, yung initial velocity is 30 meter per second and the final velocity is 0 meter per second. Kanina kasi baliktad yun. Okay, so here, makikita nyo that the acceleration should be negative 8.0 meter per second squared. Bakit negative? Because it skids to stop, therefore it will decelerate. Expected natin na pabagal siya kasi papa-stop siya. So, it will be negative. So, with that, we'll be getting 56.25 meter as the displacement, okay, that the car take during the skidding process. Okay, so that's it.